Welcome to this new problem. In this problem, we will see how to solve or get an LCM of a pair of numbers. So let's take some examples to see what is about LCM. LCM stands for least common multiple. Okay. So let's take this 3 and 7 as an example. Let's say we have two numbers 3 and 7. Okay. So what is the common multiple for 3 and 7? So you see 7 into 1 is 7. So I do 3 into 1, 3. 3 into 2, 6. 3 into 3, 9. Okay, it doesn't match. So 7 into 2 is 14. So 3 into 4 is 12. 3 into 5 is 15. Again, it doesn't match. So let's do 7 into 3, which is 21. Now 3 into 6 is 18 and 3 into 7 is 21. You see, we have this 21 common in both 3 and 7, which is the least one from whenever we try to multiply it from one, right? So this is what is known as least common multiple. So the least common multiple of 3 and 7 is 21, and it is also known as co-primes because both are prime numbers. So if a number both the numbers are prime numbers, if you just multiply the prime numbers, then we get the LCM of those prime numbers. Those are called as co-primes. Great. So now let's see another examples. For example, in the case of 4 and 6, what is the least common multiple? For 6, if you add one more 6, it is 12, and 4 into 3 is 12. So 12 is the least multiple. And for 3 and 4, it is going to be 12, right? Because 3 times 2 is 6, 4 times 2 is 8, 4 times 3 is 12, 3 times 4 is 12. So 12 is the least common multiple. And for 2 and 8, you see 2 into 4 is 8. So 8 is the least common multiple. And for 3 and 7, we have already seen. Okay. So let's make use of this fact and let's go for a naive solution first. How do we go about this naive solution? See, it's kind of like an opposite of what we did in GCD, right? So here, the least common multiple cannot be smaller than the maximum of two numbers. So in this case, what you need to do is like get the maximum of two numbers. For example, in the case of 3 and 7, maximum of 3 and 7 is 7, and then increment the number 1 by 1. Like just increment by plus until you meet a common multiple that is divisible by both A and B. Okay, so I have given you a clue. Please try to solve it on your own in the coding exercise, and we will meet you in the solution video. Thank you. Okay, welcome back. Let's try to solve in a naive way. So let me create a new file, 06lcm.js. Okay, now let me create a function LCM, and this is going to take two variables A and B, both are numbers. And now inside this, what you can do is we have to find the maximum first, right? So let result is equal to math.max of A comma B. So now that we have the maximum or maximum number, which might be a possible result, now let's do an infinite loop. So while of true, inside this loop, first we will check whether result modulus A is equal to 0, and then result modulus B is equal to 0. If that is the case, we will just return the result. If not, we will increment the result by 1, and then we will try to continue. So that's all, guys. To be frank, that's all the program is. So let's try to add some test cases. So LCM, so maybe I will just copy a couple more times. So let's add test cases for 4 and 6, which should give us 12, and 2 comma 8, which should give us 8, and 3 comma 7, which would give us 21. Okay, cool. So node 06 lcm.js. Yep, as expected, we are getting the result. Great. Okay, so what is the time complexity of this solution? If you see, it starts from max, and the maximum it can go is A into B, which kind of like the time complexity is like big O of A times B minus max. Okay, so this is the approximate time complexity. And as for space complexity, we are not using any space, which it's just a constant variable, one variable. So you can take it as space complexity as big O of 1. Great. So now that we have this naive solution, the next video you have a overview to see an efficient solution. So let's continue in the next video. So what is the better solution going to be? The better solution is based on another mathematical proof. So basically, if you have studied high school mathematics, right, you might have known this formula, but even if you don't know, don't worry. But the basic idea is that if you multiply A and B, it is also equal to GCD of A and B multiplied by LCM of A and B. Okay, so basically if you multiply GCD and LCM of a number A comma B, then you get the multiplication A into B. With this, now we can figure out the LCM by moving this GCD towards the left hand side. So LCM of A comma B is equal to A times B divided by GCD of A comma B. Now we already know how to calculate GCD based on the previous lectures. So it takes logarithmic time complexity. So once we know the GCD, it's as simple as doing a constant mathematical operation to calculate the LCM of A comma B. So the overall time complexity it's going to take is the time complexity of GCD. Okay, so I hope I have given you a clear indication of how to go about this solution. In the next coding exercise, please try to solve it on your own, and I will see you in the solution video. Thank you. Okay, welcome back guys. So let's try to do the efficient way. So let me create a new function, LCM underscore better. I'm just naming it, some naming, and A comma B. Now we just need to return, if you remember from the formula, A times B divided by GCD, right? So I will do A multiplied by B divided by GCD of A comma B. That's all. And let's try to add the same test cases, at this time with LCM better. But if you see, we need to have a definition for GCD. So let's go to gcd.js, and probably we will use this iterative solution, okay, because this is the efficient one, right? So let me copy that and just change it to GCD. Now we have this GCD functionality which will give us the GCD in logarithmic time, and yeah, we have this formula put up as well. So let's try to run. So node LCM, you see we are getting the same output. So it's as simple as this. But if you are not sure about how this GCD function works, please again take a look on the GCD video. Okay, so overall this solution works in a logarithmic time. So log of min of A comma B, right? Basically, yeah. And if there is no space complexity, it's just big O of 1, because here we are using an iterative GCD. Great, cool. So that's it for the solution. See you in the next one.